You can look at your notes. What's a conditional? It is a statement, but there's something special about it. It's in what form? If-then form. Okay, so just remember a conditional is just a sentence in if-then form. Because now today, we're going to take those if-then forms and jumble them up a little bit. Yeah, no, it won't be anything confusing like that.
Can we review them a little bit?
What's that?
The if-then?
It's just a sentence in if-then form, that's all. But we will review. So we have three different ways we jumble up these conditional statements. The first way is the inverse. So your inverse is when you negate the hypothesis and the conclusion. So in symbol to be not P implies not Q.
What does negate mean?
Remember that's you take like the not. Like if I said no, it's a good question. Remember, negating just means to change the truth value, so you put not in front. So not P implies not Q. The converse is when you switch. Yep, I can go back. That's okay.
Okay, we're good. Thank you.
Okay. Converse is when you switch your order. So the hypothesis and conclusion switch spots. So that time, this time it's going to be Q implies P.
It's really strong in that. It's mysterious. It's huge because it's usually
And then the last one is the contrapositive, and that's when we do both. We negate them and we switch the order. So not Q implies not P.
This is already
I know, and I always say this, it will make more sense when we do the example together, I promise. We just gotta get the definitions down so you can look back during homework time.
I like writing pages.
You like what?
Writing pages.
Yeah. Okay, should we try one?
This doesn't make sense.
I know.
Where do you get those things?
I just Google them. I thought that was funny. Okay, so we are going to write the inverse, converse, and contrapositive of this conditional statement. So if it is Saturday, then there is no school. So let's just start by doing this. Let's put P up here, because this is my P, and here's our Q. Right?
So if it is inverse P, if it is
What does P stand for?
P is just how we represent this part of the sentence.
Q is no.
So would it
No.
be?
Okay, hold up. Don't get ahead of me. Okay, what's our symbols for inverse? What does it say?
It's, the squiggly line P, arrow, squiggly line Q.
So write that down. Not P implies not Q. So now, how do I write not this first part?
If it's not Saturday.
That's it. So write that. If it is not Saturday. I know. Then we want to put not Q, so I'm going to write then
There is school.
there is school. And then we need to decide, is that true or false?
False.
If it is not Saturday, then there is false.
Still false.
It could be Friday. It could be Sunday.
It false because it could be what day? Sunday. Yep. So let's put false. Could be Sunday.
What if someplace there is school on Saturday?
Okay.
Or like I have to go on school on
There's
Saturday
school.
because of a certain reason.
I know. I mean, we could play the hypothetical games, all day. We really could. But let's just, for like our norm, we don't have Sunday school, right? Or school on Sundays. So you might go to Sunday school. See, that wasn't so bad, right? When you put it, like, break it down, kind of.
No, just right what we did yesterday.
Okay. What's our symbols for converse?
Q arrow P.
Q implies P. So all we do, folks, write it backwards. So this time it's going to say if there is no school, then what?
It's Saturday.
Yep.
Which is false.
Would that be true or false? Why would it be false?
Could be Sunday.
Could be Sunday. Good job, team. Could be Sunday. Okay, and then in symbols, what's our contrapositive? Oh man. What did we write in our notes?
Squiggly line Q,
Yep.
arrow, squiggly line P.
So squiggly line means not, right? So not Q implies not P. So I want the not of our Q's. What would it say?
There's school,
And
and it's not Saturday.
Yep.
there is school.
If there is school, then what?
True. Whatever.
Then
It's not Saturday.
then it's not Saturday.
yep. Is that one true or
Yes.
false?
Oh, that was true.
Yeah, because we don't have school on Saturdays,
Yeah.
right? If there is school, then we know for sure it's not Saturday. It could be Monday, Tuesday, Wednesday, Thursday, Friday. We just don't go to school on Saturdays. That would be terrible. We all need a day off. Right? Right. I say you take off more than that.
I'm going home.
Okay, drive safe.
I will.
Bye.
Bye.
Okay. How do we feel about that? Do we like it? No, I know. Okay, the last thing we're going to talk about today is a biconditional statement. This is when the conjunction of a conditional and its converse are true. So in symbols, this reads as P if and only Q. And again, this is only true when both your conditional and your converse are true. If one of them is false, then we already know our biconditional is false. And I know you're probably like, why are we learning this? Like, this doesn't make sense. Everything we do is so different. I'm trying to get your brain to work differently so when we make our proofs, you know how to think outside the box. Okay? We're getting close to that writing the proof stage.
We have to write them.
Write proofs? Yeah.
What are they?
Like, I'm going to give you a picture of a segment. You have to prove why B is the midpoint. Yeah. But you can't just say, well, because it is. You have to use our logical reasoning that we've been kind of working on to write it. Right, 'cause that's what we want to say. It's so obvious why it is, but you have to explain why.
That is explained.
Because it is.
No, because it is in the middle of point blank.
Right.
Yeah.
We'll find out on Friday.
So it's gonna be way more.
It will be.
We do them on
Okay, let's skip this one for now. Let's do the little smaller piece because that makes more sense. Easier example to start with. So can we do this? So we're on the second little sheet. Did everyone get the little sheet?
Yeah.
Let's do that one first. So we have this statement, lines do not intersect or parallel. So first we need to write it as a conditional statement, which means what? What form? If then form. So what would that look like?
If lines do not intersect, then they are parallel.
Yep, so if lines if lines do not intersect, then they are parallel. So now we need to decide, is that true or false?
True.
We want to say true, but we have a thing called skew lines that aren't parallel, but they never intersect. They're on separate planes. So we're going to say false because I'm telling you to write it. We haven't talked about it yet. And you can write skew lines. Okay, now we want to write the converse of this if-then statement. So the converse is what? Look back at your notes. What symbols is it?
It's Q arrow P.
Yep.
So if the lines are parallel, then they do not intersect.
Yep, so if lines are parallel, then they do not intersect.
Holy grass. Holy grass. It's the size of
Is that one true or false?
That'd be
That's true. We know parallel lines don't touch.
Isn't it naked or
you said true because the first one's false.
We have good odds.
Isn't it squiggly line Q?
That's contrapositive. This is a converse.
Oh.
Good question though.
Sweet.
Okay, now the biconditional,
Equal.
you're not gonna set an equal, you're gonna say, you wanna know? Before I tell you? Biconditional, the if and only if.
The conjunction of its conditional and
yeah.
its converse.
Yep.
Yeah.
So lines do not intersect if and only if they are parallel.
False, because it's just a long way, right?
Lines do not if and
You have homework today.
yeah. And then what would the truth value of this biconditional be? If you go back to your notes, it says biconditional statements are true when both. Are both of them true? Did I get true?
Techno.
No.
So this is automatically
False.
false because our conditional.
What's it? What's the name of this? Alright, can you show me?
Yeah.
Actually,
Yeah, we aren't going to do that first one. I'd rather just help you during your homework. You might really be confused. We might end up doing all of our homework together today. Who knows?
oh, perfect.
We don't know how it's going to work out.
Yeah, I think so.